Hey guys, we're going to make a simple cycle timer so that when a PLC goes into run mode, it will start accumulating here. This is the cycle time per part. And when a cycle completes, we get another part. We'll also get an average cycle time here. So every time it completes, we have 2 parts in about 13 seconds, about 7 seconds each. We'll do it again. So our instantaneous cycle time, about 5 seconds. Average cycle time, we're getting about 24 seconds, 6 seconds apart, 4 parts. So that's how that's going to work. So the cycle timer kind of has 2 main parts, I guess. The first is the actual timer that just counts up. So we have 1 per part, and then 1 is the total running time that we can divide by the total number of parts. Then the other part of this is a function block that we will write that will format the time into however you want the string to be so you can display it on an HMI. All right, let's start with a brand new project. Cycle timer demo. We have an NX102 9000 1.6. Great. All right, first thing we're going to do is create a new function block with structured text. Open the function block. We will call this. I like to prefix everything FB for function block and then cycle timer. Let's start with our variables. All right, let's start with in-out and basically have the FB in, which is just the is running. Press insert to create new entries. I'll have FB out is saying it is running. That'll be an output. Then we have time in, which is a time type. We will have time out, which is going to be a string. And then n parts, which is how many parts have currently been processed, which is an int. All right, internals, going to have a few more. So basically the way Omron works is you get your time in either seconds or nanoseconds, which can be a little rough for converting, but that's what this is going to do. So first thing is we're going to have time in nanoseconds, which is a long int. Just create a bunch. We're going to have the minute string, second string, hours string, and milliseconds string. I'm sorry, ms string, millisecond string. These are all going to be string types. We're going to have milliseconds, seconds, minutes, insert to add another one, and hours, and then 2 more, which is total milliseconds and total seconds. All right, that's all our internals. All right, so we only want this to run if we have that input that says to run, which we called FB in. So if FB in, then. And first thing we want to do is get our nanoseconds. So time in nanoseconds equals time to nanosec, time in. Then we want to divide this if we have multiple parts. So if n parts greater than 0, then time in nanoseconds equal time in nanoseconds divided by n parts. And end. All right, this is going to be the total milliseconds and seconds. So this will be total milliseconds equal time in nanoseconds divided by, it's a million, one more 0. And total seconds equal total milliseconds divided by 1,000. All right, so we're going to use this. So basically we got the time in nanoseconds from our input time, which is just going to be our running timer. If we have multiple parts, we're going to divide it to get the average, and then when we do just a single part cycle timer, it'll just be 0 or 1, so we don't actually divide it. And now that we have the total milliseconds and total seconds of our nanoseconds, it's going to be a little easier to manipulate. So let's convert this to hours, minutes, seconds, and milliseconds. So hours equal total seconds divided by 3600. Minutes equal total seconds mod 3600 divided by 60. Seconds equal total seconds mod 60. And milliseconds equals total milliseconds mod 1000. Okay, this milliseconds equals total milliseconds mod 1000 is kind of weird. And the reason for it is, if you think about it, say we have like 1, 2, 3, 4, 5 total milliseconds. We've already counted the 12 seconds above, so we only want that 3, 4, 5. So we mod it by 1000 to only get the last 3 digits of the total milliseconds. It just kind of looks funny. All right, after we have our conversions, what we do is convert them to a string. So this is what you'll display in the HMI. So hours string equals lint to string hours. And just do this for all of them. All right, and now that we have the strings, we need to add leading zeros if you kind of want to display it nicely. And this concatenate is how you add basically any string to a already existing string. Okay, and then the last thing is to create our display string. So I like to kind of do this if, if a part only runs for a few seconds, there's no point in displaying the hours. But if you want like a total runtime clock, how long its machine's been running, that day or week or however long it is, then maybe you want hours. So we would do this by doing, if hours is greater than 0, then we will include timeout as our output variable that says it's our output string variable. So then we're going to concat our string colon minute string another colon sec string. And generally, if you're displaying hours, milliseconds don't matter, so we haven't added milliseconds here. But if you want it, feel free. All right, as long as minutes are greater than 0, timeout equals concat min string colon sec string. Else we only have seconds and milliseconds. So again, if you are displaying minutes, milliseconds probably doesn't matter. Then a period for milliseconds, not a colon. All right, end. So that will create our string based on how much time has passed. And then I usually just do the output will be FB out equals FB in. So no input, no output. All right. You do check program. Oh, we need to make timeout and output. and include it then. But we got it this time. Oh yeah. All right, function block done. Back in the main program, what we're gonna do, we'll do an is running variable. So this will be just your program's in run mode. It's processing. It's doing its thing. Is running global variable. Now we're going to have two timers. So we're going to have the per part cycle timer, and we're going to have a running average cycle timer. So two function blocks. I generally prefix, we'll choose, so the function block, the one down here, needs to be the name of it. So FB cycle timer. And then I usually prefix the name of it. This will actually be a part cycle timer. And we're going to have another one, which is going to be average cycle timer. All right. Then we need two accumulation timers, which you can find down here. We're going to have timer part and copy paste timer average. All right, so this will be the running timer for our parts, running timer for our average. We'll need a little more, well, let's fill these out. So time in is going to be cycle time. We will create this. It will be an internal variable, and it's going to be the elapsed time of the accumulation timer. Just as we're going to do time in here, we'll do total time internal, and this will produce the total time. So the elapsed time of the timer here becomes the input of our average cycle timer. All right, and then the set point for each of these, I just set to a absurdly high number, so they never get reached. And then reset, we'll have reset cycle timer, internal, reset average timer, internal. So for the per part timer, if you remember in our code, we actually said you only divide it if it's if we have more than 0 parts. But I usually just put a 1 in here just because it makes it pretty obvious we're only ever calculating 1 part. So this is will be what you display in your HMI. So we'll just call it however you want to do it, but cycle time per part global, and this will be your HMI cycle time average. Cool. And then this, how many parts, end parts. So we'll calculate that in a little bit. Internal. Okay, we need a little more logic. So this is it. This is your cycle timer. So as long as you're populating some of these values and parts somewhere and using them somewhere, this will work. But we're going to create kind of the demo code after this. So we will simulate our main cycle complete. So this is every time your process finishes a single cycle. We want to reset your cycle timer. So that's up here. So every time a cycle is completed, we reset our timer. That'll reset this back to 0, and then you can just start calculating the next part's time. Rising edge. And then we want to increment the parts. There's a couple ways you can do that. There's this inc function, increment. So we have n parts. It increments it by 1. What I kind of like doing instead is using like an inline function. N parts equal n parts plus 1. It's just a lot smaller. Sometimes if you got a lot of stuff going on, an increment is just like absurdly large, and this you can kind of just shrink up very nicely. So we're going to keep it like that. Then we're going to have, so the average, usually the way I do it, you can do it however you want. It's like user resettable, or sometimes like when they start a new cycle, maybe it's resettable. Regardless, we're going to make this user presses reset. So when the user presses reset, we will reset our part count. So we're just going to move the value of 0 into n parts. So that resets n parts. It would be the same as doing n parts equals 0, if that's your thing. But upon user presses reset, we need to reset the average timer, and we need to reset the cycle timer. One thing to note is we actually need to reset the cycle timer from 2 places. And in ladder logic, you can't use the same variable on 2 lines because they will change each other's state, essentially. So we're actually going to call this number 2. We'll call this number 1. And we're going to create a new line that says if we get a reset cycle timer 1 or a reset cycle timer 2, we will reset our cycle timer. All right, so this line finishes as 1, this is 2. Either of them are true, we get number 2. And these are both rising edge contacts, so these will only ever fire for 1 cycle. Cool, so that's our test code, and that should actually do it if we wrote everything correct. So we will start the simulator, press F5. All right, we'll do our is running variable. So this is, user presses start, everything's good, it starts running, we start calculating our part time. 0 parts. So every time a cycle completes, we'll say about 5 seconds, we'll make it go to 10. We increment our part count, our average time. This takes a little bit of time to even out, but this did reset. So let's wait till it gets to about 10. Hit it again. So now this resets. This is going back. We'll wait one more time. All right, we get to about 10. So we have about 10 seconds, 31 total, 3 parts. That makes sense. So whenever you finish a part, increment it, and our average is starting to average out. 4 parts, 43 seconds, 11 seconds each. That's about right. Then if you take it out of run mode, we would need to, so it holds on to it, retains our values, which is cool. We got our average, we got that. And then we can reset them, set this to true. We reset both timers. We set this to 0. This still has the last time, which is fine. You can change that logic if you want. And then as soon as we start running again, we reset both values. That's what we want. Cool. Enjoy.